Good afternoon, all of you. Today we are going to discuss the problem on root locus technique. Okay, root locus to find the stability of the system, control system. So here we have the question. This is feedback, unity feedback, and this is forward path gain. G of s equals k by s into s plus 1 s multiplied by s square plus 4s plus s. Okay. So the first step is here we have the solution. Rule 1. First we have to write the transfer function. Okay, this is g of s and it is h of s. What is number of poles and number of zeros? How can we find? The numerator is known as number of zeros. Okay, and denominator is known as number of poles. As we can see here in the numerator, there is no s. Okay, so number of zeros are 0, and number of poles in the denominator, as you see here, s equal to 0, s equal to minus 1. Here we have two two roots. Okay, so 1 2 3 4, so there are number of poles equal to 0 in the numerator. Now rule number 1, number of branches. The root locus have branches or number of branches. Okay, how can we find n minus m? Number of poles minus number of zeros, that is 4 minus 0 equals 4 branches. Okay, so we have known that there are 4 branches. Real axis root locus. So to find this real axis root locus, how will find the roots? So d of s, that is d of s is equal to 0, denominator equal to 0. So s equal to 0, this is one root, s equal to minus 1, s equal to minus 2 plus minus j, s equal to minus 2 plus j. By the denominator, by this equation, you can find these roots. Okay, there are 4 roots. So indicate on the real axis. This is real axis, this is imaginary axis. So we have s equal to 0, s equal to minus 1. This root locus, this have imaginary axis root locus, and these 2 points, these two locus, these 2 points are s equal to minus 2 plus j, s equal to minus 2 minus j. Okay, this is known as real axis root locus. This is rule 2. Rule 3, start end points. Start point and end points. Start point, you know, the poles are the starting points, s equal to 0 is one starting point, 2 3 4, there are 4 starting points. K equal to 0, that is d of s equal to 0. So end points will be at infinity. Why? Because we don't have zeros. The root locus starts from poles and ends at zeros. Since we don't have 0, k equal to 0, d of s equal to 0, we don't have zeros, the endpoints will end at infinity. Is it clear? In our example, no zeros. That's why endpoint located at infinity. Starting points are poles, 4 starting points. Endpoints are 4, that will be at infinity. Rule number 4, asymptote direction. What is the formula for asymptote direction? Asymptote equals alpha equals 2k plus 1 by n minus m multiplied by pi. So n minus m is 4, and for k equal to 0, we have to find the asymptotes like this. Take 4. Why? Because we have 4 poles, k equal to 0, k equal to 1, k equal to 2, and k equal to 3. Okay. As you substitute all these values in this, you will get the alpha value. These are asymptotes. Okay. Pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. You can see here. Here, these are asymptotes. Pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4. Okay, asymptote. This. So centroid you have to find. These are asymptotes. Now, abscissa of the intersection between asymptotes and the real axis. Abscissa. That is centroid. Where is this point centroid? We have to find. The formula for this is x naught equals number of sum of poles minus sum of zeros by n minus m. What are poles? 0, minus 1, minus 2 plus j, minus 2 minus j, minus number of zeros are the zeros, not number of zeros, zeros. Zeros we don't have, 0 divided by poles minus zeros, that is 4. Okay, you got the value as minus 1.25. This is asymptote. This is centroid from 0 up to negative 1.25. This is centroid x naught. Okay, real axis, imaginary axis. Now rule number 6, breakaway point and break in points. So how we will find this? Sigma 1 by s minus si equals sigma j equal to 1 to m 1 by s minus zj. This is 0, this is pole. So in our case, no zeros. So this will be 0. And we have only this on the left hand side. We have to add 1 by uh, s minus 0 plus 1 by s plus 1. These are our roots. 1 by s plus 2 minus j, s plus 2 plus j. Minus of minus, both will be plus. Is it clear? Then by this equation, you will get this. By this equation, okay, equal to 0. You got this. Rule 7, breakaway points. We will find how this is our standard equation equal to 0. So this will be equal to 0. This is standard equation. After you multiply all this, you will get this. Now find s. How? S1 equal to minus 0.393. S2 equal to this. S3 equal to this. By this equation, you can find S1, S2, S3. We must take S1 because it belongs to root locus. See rule 2. Rule 2. And we must take this. S equal to minus 0.393. So after this, rule 7. Imaginary axis crossing point. It's obtained from characteristic equation for s equal to j omega. There is another method also. We will use this method. Okay, this is the standard equation plus k equal to 0. Substitute in the place of s as j omega. After you substitute, you will get this final equation. So if you take common as j, you will get two equation. This equal to 0, this equal to 0. Okay, if take j as common, this and this, and remaining terms, this term, this term, and this term equal to 0. There are two equations now. Now we have, shall we flip this? Right. So there are two equations now. Minus 5 omega cube plus 5 omega equal to 0. Then we will get the values of omega as omega equal to 0 and omega equal to 1 by this equation. By this equation, you will get omega equal to 1 and k equal to 8. If you substitute, if you take omega equal to 1 from this and substitute in the second equation, we got here two equations here. Okay. two equations, this and this. By this equation you will get omega equal to 0, omega equal to 1. By this equation you will get k equal to some equation. If you substitute omega equal to 1, k equal to you get 8. Okay. By the help of this we can draw the root locus and angle of departure. This is important. How the angle of departure? Angle from zeros on the imaginary axis. On the imaginary axis, from this point theta d distance. Okay, from here to here 90 degrees. From here to here you can calculate it is minus 135 degrees, and from here to another 0, these are zeros, s equal to 0, s equal to minus 1. Okay, take any one pole and draw the lines, connect the lines and find the angles. This is 153. So the formula is 180 minus 90 plus 135 plus 153. So you will get 198.443, or you can get 161.57 degrees. Okay, what is this? This is 161.57. From this zero, from this pole, where is the root locus? Starts from here, and draw a perpendicular line here. Okay, perpendicular line to the real axis and take 161.57 degrees, and root locus will start from here and it will travel like this up to it reaches to at infinity at 0. In the same way here, minus 161.57. Draw the perpendicular line here at this pole and take the angle as minus 161.57, and start point is at pole and it goes to infinity. Is it clear? And now what is this point? This point is omega equal to 1, omega equal to 1 at the same pole. It will cross the imaginary axis. From here, this is the one starting point, s equal to 0, this is s equal to 1. This is centroid 1 minus 1.25. Here we have minus 1. This is one of the pole. One of the root locus starts from here and join here, and one of the root locus starts from here and join at this point. This point is 0.393 as we took from here. 0.393. Okay, it crosses this point, and one of the root locus travels along the asymptote, upper asymptote, and one of the root locus crosses the another asymptote. Okay, when k equal to 8, k equal to 8. Okay, this is root locus. I think all of you understood. This is about, you can practice more problems. If you have any question, you can message me here. Okay, thank you.